Greetings. So today we are focusing on derivatives from first principles. This will be the very first question under the topic calculus in your paper 1 examination. It will always be there. I think it will contain 4 to 5 marks. So you really need to have the skill or like a knowledge of how to approach it, and I can promise you that it's the easiest thing you can ever find in your mathematics paper 1. So what you need to know is like what is a derivative first. So a derivative is a gradient. Derivative is a gradient of a curve. It is a gradient of a curve or gradient of a graph. Okay, so when they say find a derivative, like that answer you get for the derivative is actually the gradient. And then the notation for it, the derivative of f of x, for example, will be f prime of x, or p of x. The gradient or the derivative of p of x would be p prime of x. So that this is just the notation that you use. Notation. And the formula, you also need to know the formula for calculating the gradient of a curve. So the formula will be for specifically for f of x. Let me just change the color. For f of x, you will have f prime of x equals to limit h approaching 0, then f of x plus h minus f of x divided by h. So this will be the formula that you will use to calculate the derivative of f of x or the gradient of f of x. Okay, this is your formula. But now let's do 2 examples to try and make sense of what I just said. So example 1, or like the first question, let me just write it down. So the question is find the derivative of f of x from first principles. Then 1.1, when f of x is equal to x squared plus 4, and question 1.2, it is when f of x is equal to 1 over x. I think it's 4 marks, and this one would be 5 marks. Then we need to calculate this. Then in the next page I will solve these 2 questions, and if you have any questions or concerns, there are contact details under this video. Then you will like direct your questions to me. Okay, so let's try to answer the previous question. Let's just remind ourselves we had x squared plus 4. Actually, this is wrong. We had f of x equal to x squared plus 4, and we had f of x equal equals to 1 over x. So with the solutions, I will start with number 1. Actually, it was 1.1 and 1.2. This is 1.2, this is 1.1, and I will start with 1.1. Okay, so our formula is, because we're looking for the derivative or the gradient of f of x equal to x squared plus 4. So we're looking for f prime of x, which is equal to limit h approaching 0, f of x plus h minus f of x, all divided by h. So this is what we are looking for. Okay, the skill that I use to solve this is a bit different. Before I substitute and do everything, I have to find out f of x plus h separately, because at least I know f of x is equal to x squared plus 4. Hopefully that's clear. Let me just write it. I think I'll write it there at the corner, and I will say f of x is equal to x squared plus 4. At least now I have f of x. I need f of x plus h. F of x plus h. Okay, this is f is equal to, this is the trickier one, because when I substitute here, I want things to be simple. So what is f of x plus h? That means where there is x, you put x plus h, because here it's f of x, and where there's x, there's just x. Then if it's x of x plus h, then where there is x, you put x plus h. So let's do it. So it's supposed to be, the original function is supposed to be x squared plus 4, but because we're not looking for f of x, we're looking for f of x plus h, then we're no longer gonna have x squared plus 4, but we will have x plus h squared plus 4. If you do notice this, it's like this represents x, and this is just that 4, because it was f of x, and we said x squared plus 4. Then for f of x plus h, instead of putting x squared, we say x plus h squared, because it's not f of x, but rather it's f of x plus h. Hopefully that was clear. Okay, then when we go down, its limit h approaching 0, then f of x plus h, we know it is x plus h squared plus 4. Or let's just simplify that before we move along. This is equal to x squared plus 2xh plus h squared plus 4. This looks like this. So when we go down here, we'll just take that. We'll just take that, and we will say x squared plus 2xh plus h squared plus 4. This is f of x plus h, because we got this when we were calculating f of x plus h. So we're here to substitute f of x plus h, then we put the answer for f of x plus h. Then we say minus f of x. Simple, there is f of x. Then minus f of x. F of x is x squared plus 4. We close our brackets. Then we divide by our h. and we say equals to. Okay, then now it's limit h approaching 0. Then when you solve this, if you see x, it will be over with x squared. It will be over with 4. 4 will cancel that one because this one will inherit a negative sign, and you will be left with 2x h plus h squared. Due to time, I'll try to be faster, over h. Then you will say limit h approaching 0. Then you will have h as a common factor, and you'll be left with 2x plus h over h. Then you will be left with limit h approaching 0, 2x plus h. So then you will say equals to 2x plus 0. Like you always put 0 for h. Then your answer will be 2x. I will rush and do the second example in the next 3 minutes that's left. So let's quickly do this. 1.2 f prime of x is equal to limit h approaching 0, f of x plus h minus f of x divided by h. Then we have to do that separately as I suggested before. Then f of x, okay, let me change the color of my pen. Okay, f of x is equal to 1 over x, and f of x plus h must be equal to, instead of x you put x plus h, x plus h, 1 over x plus h. Okay, then let's rush to calculate that in the few minutes that's left. Okay, then we say here equal to limit h approaching 0. Then f of x plus h, here is f of x plus h. You have 1 over x plus h minus f of x. You've got f of x here, which is 1 over x divided by h. Then you find your LCD the normal way. Then you will have, when solving this, like you find the LCD here, then the LCD there is x into x plus h. This is your denominator. Then on top there times there, then you will have x minus x plus h, then divided by h, limit h approaching 0. Then so when solving that,